Hey guys, welcome to Pre-Calc, lesson 7.8, Financial Mathematics. Let's consider this example. A payment of $1,000 is made every year to a mutual fund. The fund earns 6.5% compounded annually, that means once a year. What is the value of the fund after 15 years? Show the series in expanded form. Well, this is not simple interest. It's not putting in $1,000 and letting it sit there for 15 years. You put in $1,000 every year. So let's expand this and see what's really going on. Our first deposit. All right, if we put that in a bank, that's $1,000. If it makes 6.5% interest, I'm going to multiply that by 1.065. And if it's in there for 15 years, that would be to the 15th power. Okay, so just that amount, if I put $1,000 in and let it sit there for 15 years at 6.5%, that would give me $2,571.84. But remember, we're doing this every year. So then I'd have another deposit. The second deposit would be $1,000 times 1.065, but that's only going to be in there 14 years. So that'd be to the 14th power. So that amount would be 2,414.87. Okay, let's just do one more, and then we'll get an idea of what's going on. The third deposit would be $1,000 times 1.065 to the 13th power. That would give me $2,267.49. Okay, well, let's fast forward. My last deposit sits in there for 1 year. So it's 1,000 times 1.065 to the first, which is obviously 1,065. So in total, I have 15 deposits. So if I want how much money is in the account, I need the sum of 15 terms. So this is going to be one of my sum formulas, S sub n. Well, first let's think about what type of series. Is this arithmetic or geometric? So anytime you increase or decrease by a percentage, you guys should know by now that's going to be geometric. So that's simply going to be a geometric series. Well, remember, we have a sum formula for a geometric series. What is that sum formula? It's a sub 1 times 1 minus r to the n all over 1 minus r. Well, I know this gets a little bit tricky when we're talking about percentages and r. Basically, what this is going to be, all right, is this 1.065. It's 1 plus the interest rate if it's growth, or 1 minus interest rate if it's decay. So what is the value of the fund after 15 years? Well, I want the sum of the first 15 terms. A sub 1 is $1,000. That's how much goes into the account every year. In parentheses, it's going to be 1 minus 1.065 to the 15th power. And I take that and I divide it by 1 minus 1.065. If you throw that into the calculator, you end up with $24,182.17. So that's not too bad. Now, one thing I want you to consider, this doesn't really apply to the geometric sum formula, but it applies more to the financial aspect of it. How much did you contribute over those 15 years? Well, it's pretty simple, right? 15 years times $1,000 a year equals $15,000. So you only put in $15,000, and after 15 years, you've got $24,000. And this one, in terms of saving for like retirement, is a pretty modest amount of money to put in the bank. So we're going to do some projects, or a project in this unit, where you're going to see how rapidly your money can grow when you start talking about tens of thousands of dollars over 20 and 30 years. Okay, so here's kind of what we just did. This is called an annuity. A future value, it's an annuity. An annuity is something you put money into every single year. has this formula. Basically, it's very, very similar to our geometric sum formula. These two are identical. If you just take a look, we sort of cleaned it up. You see how this is 1 minus 1 plus r. So it ends up just being an r down there. And we just kind of swapped those because this actually ends up being a negative r. So this is an easier formula to work with, and this is generally what I'm going to use, just has less terms. But what do those variables and placeholders represent? A sub n is simply our future value after n years. So it's how much it's going to be worth after 10 years or 20 years or 30 years. N equals the term, which is simply the number of years. A sub 1 is your annual contribution amount. So how much do you put in every year? Generally, you put in the same amount. Obviously, that might change slightly over the years, but the key here is annual. How much do you put in every year? So if you put in so much monthly, you had to multiply it by 12. And R is simply our interest rate. And that's going to be a decimal. And a quick example of that is 6.5%. R would be 1.065. So it really is helpful if you know how to convert from a percent to a decimal quickly. Okay, let's try an example. It's pretty straightforward. Basically, we're just plugging into the formula. You just need to know what formula to use, and then we plug in. So here we go. We have a payment of $5,500 is made every year to an IRA. We're going to assume the fund earns 7% annually. What is the value of the fund after 30 years? So we need to know what represents what. A sub 1, how much do you put in every year? That's $5,500. R, all right, is 0.07. And N, the number of years, is 30. So I'm going to plug into my sum formula. Sum of the first 30 terms. That's going to be 5,500, how much we put in every year, times 1. Now again, I'm showing you what formula I'm going to use. I'm using this one right here. 1.07 to the 30th minus 1, close your parentheses, all divided by 0.07. Again, all you're doing is plugging all of this into the calculator in one shot. Create your fraction, alpha F1, and then enter those numbers. And that gives you this pretty big number, $519,534.32. So obviously a very, very significant amount of money. Next example, I'm just going to try and mix it up a little bit. It says a payment of $1,250 is made every 6 months. Remember, let's look back up here. That's the annual contribution amount. So to start this problem, A1 is going to be 1,250 times 2 because you do it twice a year. So that would be 2,500. Our R value is going to be 0.08 because 8% is 0.08, and N is 10. So again, I'm just plugging into that formula. S sub 10 equals 2,500 times 1.08 to the 10th minus 1 all over 0.08. And that gives you 36,216.41 if my calculation is correct. So that's how an annuity works. That's how you calculate the amount of money left in your account when you contribute every single year. So the present value of an annuity or growth fund represents the lump sum. So when you retire, some companies might say, okay, we'll give you, $50,000 a year for the rest of your life, or right now, I'll give you $400,000 one-time shot, lump sum. So that would be the amount you'd have to invest now so that after N years of gaining simple interest, it would equal the amount in an annuity. So here's our present value formula. All right, notice it's got some similar parts. Obviously, A, that's going to be the amount that you would put in every year. I might as well write these out. So A equals the annuity payment. And again, that would be yearly. P represents the present value. How much would all of that money be worth today? N, again, equals the term, which is number of years. And R is your interest rate. And again, that's a decimal. So in this example, it says an annuity pays $15,000 per year for 20 years. So that is one option. The annual growth rate is projected to be 10%. What is the present value of this annuity? So how much would the company have to give you right now so you could put it in the bank, let it sit there, get 10% a year, and equal the same amount as investing $15,000 every year for 20 years? So again, it's sort of plug and chug. I'm just going to be using this formula right here to calculate that. P equals, it will be $15,000 a year, so it'll be 15,000 times 1 minus 1.10, right? That's what I'm doing right here, 1 plus R. I should have probably written out what R was, but I kind of do it in my head. That's 0.10 and then add it to 1. And that's going to be to the negative 20th power. And then you divide all of that by 0.1. And that equals $127,703.46. Now, I just want to make sure you guys understand, this does not represent how much money you'll have in the bank after 20 years if I give you $15,000 per year. This represents the amount you would need right now on day one to put in the bank and let it sit there for 20 years. So it equals the same amount as you would get by putting in 15 grand every year for 20 years. Okay, that's an important distinction. Okay, one more, and then we're going to kind of compare and contrast these two things, and hopefully tie it all together. An annuity pays $2,000 per month for 25 years. The annual growth rate is projected at 6%. What is the present value of this annuity? So again, the only thing that's moderately challenging here, $2,000 per month for 25 years. Remember, your A value is what it would be each year. So I have to take 2,000 times 12. All right, so that ends up obviously being 24,000. And I'm going to plug into that formula up above. So the present value is going to be 24,000 times 1 minus 1.06, right, because it's 6%, to the negative 25, because that's how many years I'm investing it for, all over 0.06. And that would give you $306,800.55. Okay, well, let's kind of tie this all together. All right, future value, present value comparison. All right, and then we're going to do kind of a fun example at the end. Annuity, you contribute $4,000 a year. If you earn 5.5% annual rate of return, what is the value of the annuity after 30 years? So how much are you going to have in the bank after 30 years? You put in $4,000 every year, you get 5.5% on that. So I'll go a little bit quickly here. This is my sum formula for geometric series. So that'll be 4,000 times 1.055 to the 30th minus 1 all over 0.055. So you crank that out, that gives you $289,741.91. So if you put $4,000 in a year, every year for 30 years, you get 5.5% every year. You don't take anything out. This is how much you're going to have in the bank. Well, what's the present day value of this? So this is kind of what we were doing on the other page. What I want to do now is figure out how much money do I need today to put in the bank in one shot, one time, let it sit there for 30 years. So that's going to be the annual payment, which was $4,000, if I were to get that, times 1 minus 1.055 to the negative 30 all over 0.055. So it's a different formula. That gives you $58,134.98. So again, let's compare. These are not equivalent. This does not represent how much you're going to have in the bank after 30 years. This number right here represents how much you'd have to put in the bank on day one and let it sit there for 30 years, getting 5.5% interest. So you put this in the bank in day one, let it get that interest for 30 years. Guess what? It's going to equal this. Let's show it right now. Verify your results above using the simple interest formula. Well, quick review. Simple interest formula. A equals P times 1 plus R to the T. This is how much you put in the bank. All right. This is your interest rate. T is your time in years. So let's use the numbers from up above. My present value formula is my present value amount is $58,134.98. My interest rate would be 1.055, and I'm taking that to the 30th power. Well, put it into your calculator, guys. This is kind of interesting. What you get by doing that is $289,741.91. We'll compare this value with what we set up here. Look at that. It's the same. So if you take $4,000 a year, every year for 30 years at 5.5%, you'd have this much in your account. Or if you take this amount of money, $58,000 and change, one time and let it sit there for 30 years, you'll end up with the same amount. So it's kind of a good idea to know how to do this number, because let's say, what if your company says, okay, we'll give you $4,000 a year every year for 30 years. Or right now we'll give you $75,000. Well, you look at this and say, well, this is the break even. If they're going to give me $75,000, I'm going to take that. That's way better. Or what if they say, no, we'll give you $40,000. You're like, no, that's not enough to break even. Okay, and the last example, and this is kind of interesting. One thing you probably know by now, that I am already a millionaire, because the Mega Millions is up to $432 million. The entire math department is playing, and I'm pretty sure we've already won. Okay, now this drawing is going to be on the 15th. So I don't know when you're watching this. I might already be a millionaire. So when it says the jackpot is 432 million, it's not really 432 million. That's the amount after a 20-year annuity. And I'm going to assume we get 5.5% growth. I don't know what they use as a growth rate. I'm just making that up. So what does that mean? Well, let's use this formula and figure out how much you're actually going to get every year. So to do that, I'm going to take this 432 million and put it in for A sub n. If you want that to be the amount in your account after 20 years, how much do I need to put in my account every year? So that's A sub 1. I don't know what that is. We're going to solve for it. So if my interest rate is 5.5%, this will be 1.055 to the 20th minus 1. All of that over 0.055. Now, what I need to do is I need to solve for A sub 1. So basically, I need to multiply both sides of the equation by this reciprocal. So A sub 1 equals 432 million, as such a huge number, times 0.055 over 1.055 to the 20th minus 1. And that comes out to be $12,389,470.58. So those of you that are 18, you go out, you buy a Mega Millions ticket. You're the only winner. You think you're getting $432 million. Guess what? They're going to say, nope, we're going to give you $12.4 million every year for 20 years. If you get 5.5% interest after 20 years of getting this amount, then you will have 432 million. You're like, okay, well, forget that. I don't want that. I want a lump sum. I want all my money up front. Sure, okay. Let's use our present value formula then. So using the present value formula, if you want to figure out how much you need up front, you're calculating for P. You need to use this number right here, right, as your A. So that'll be 12,389,470.58. And then we fill in the rest. 1 minus 1.055 to the negative 20 over 0.055. You throw all that into the calculator and you get a lump sum value of $148,058,912.20. So you win the lottery, you say, I'm taking the lump sum, I'm going to get 432 million. No, you are not. You will get 148 million. And then what they expect you to do is put that in the bank at 5.5% interest for 20 years. And then, we'll show it here in a second, you will have your 432 million. Now, some other lotto math here. Obviously, you don't take this home. You're going to lose approximately 50% of that, not quite, but almost 50% of that to taxes. So really then you're taking home about 75 million. So you might think, oh, look at all this, 432 million, but you take home 75 million. Not really a bad take home if you ask me, but let's just verify that our lump sum here after 20 years will get us that 432 million. So let's do our simple interest formula. A equals 148,058,912.20 times 1.055 to the 20th. And guess what? I think it's within a few cents. 432 million. Okay, so kind of neat financial math. We're going to do a project that involves contributing to an IRA where you guys might see, oh, wow, those of you interested in the business field, you're going to be using this. You're going to be using Pre-Calc. And it gets even more complicated when you start talking about the stock market and investing in that nature. So anyway, thanks for watching, guys. Hope you found this helpful. Please reach out if you have any questions, and we'll see you in class soon.